Everyone. So I have given this presentation twice before, one at the Better Buildings Conference, and then the other time I gave it at our Best Practices Exchange, which is happening next week. It's for some of our largest customers that have a lot of electricity load. And the reason why I came up with the idea of giving this presentation is that at Efficiency Vermont, I'm in the engineering group and I work directly with customers. I have so many people coming to me saying, I want to electrify. And it may be a building with a giant boiler. It may be a library that's got 2 steam boilers. And it's really not as simple as just throwing in some mini splits, and how we want people to really think about the steps to ensure that whatever electrification they do is successful. And it doesn't necessarily mean that you're going to do the whole building. It could be just some baby steps to electrification. So let's get started. I would just want to spend a little bit of time about electrification. It's not just mini splits. There's quite a few things that fall into the electrification category. And then the meat of it is really the best practices and a checklist of things that you should do. And there's 3 key things, which is air, seal, and insulate, downsize, and then undersize. And I have a project example, a real building, and then we'll end with some key takeaways. I want people to ask questions if they have questions, because I want people to be able to follow along and understand what I'm doing throughout the whole presentation. So when we talk about electrification, the biggest things that come up are the first 2, your heating and your domestic hot water. But we're also seeing a pretty big push for electric kitchen equipment in both the commercial and residential market, especially in the commercial kitchen. I've worked with some ski areas that have to pull their propane up the side of the mountain using a snowcat in the wintertime in order to do things like fryers, dishwashers, ovens, griddles, and how they want to electrify so that they can reduce the amount of propane that they have to pull up the hill. And the prices for electric kitchen equipment is pretty high, but my understanding is there's some things you can do that will reduce the overall cost and potentially come out at an equal cost by not having to do a lot of the ducting of combustibles. Then in terms of transportation, this is really a big one, cars, trucks, but we're also looking into snowmobiles and other modes of transportation that previously, like snowcats and forklifts, are going all electric. And then small engines, you've got your chainsaws, your lawn care, your golf carts. And industrial manufacturing as a whole is a tough one to crack with electrifying, especially in the process world. We're doing some baby steps with domestic hot water and some heat pumps, like in offices or maybe on rooftop units. But for this presentation, we're just going to focus on building HVAC electrification. And I see it as falling into 3 categories. You've got your air source, which is this picture on the far left. That's your typical system that you're going to see in homes and maybe apartments and some commercial spaces. Then the second one, which is starting to gain some traction, is the air to water. The trick is they're very expensive on the commercial level. And you're making hot and cold water outside, which is an issue unless you have really good freeze protection. And getting them to operate down at cold temperatures and still have really high capacity is a challenge. And then the third category, which is also gaining some traction. Am I sharing screen?
Yes.
And you can see that, were those covering you?
I can see your ways to electrify.
Okay, because I had some other screens up over covering that, and I just realized that. So in the third category is groundwater, or using the well shaft as a way to heat transfer. And the reason why this is gaining some traction is Efficiency Vermont has an incentive, and there's also a federal tax incentive of 40%. So we're starting to see these types of systems go in. The benefit is that they don't, you don't have to really worry about the cold temperatures because the ground is the same temperature year round. So you have more efficient heating and more efficient cooling. But for this particular example, we are just going to focus on air source heat pumps. When I work with customers, one of the first things I ask is, why do you want to electrify? And it kind of falls into three categories. Are you doing it because you want to save money? Are you doing it because you want to get off of fossil fuel and maybe not have to worry about the volatility of oil and propane going up and down? Or maybe it has something to do with carbon goals or sustainability goals of a company. A lot of the bigger companies in Vermont do have sustainability goals, and going after fossil fuels is a great way to reduce their carbon footprint, and also utilizing heat pumps that are on electricity, which a lot of people would categorize as renewable because it's coming from hydro in the state of Vermont. What I tell people is, if your whole reason is just to save money, then we need to have a discussion and do a few calculations before you decide to move forward. Because if you're on natural gas and you switch over to heat pumps, you might just be breaking even. Or if you're running on wood or wood pellets or cordwood, you may actually be spending more money. But if you're using oil or propane, you usually see some sort of a financial savings. And in my example, I'll show you what that financial savings looks like. A few important details about heat pumps that I would want to communicate to my customer before moving forward. Number one, heat pumps are not as easy to troubleshoot as boilers and radiation. So if I have a customer that right now has a couple boilers, pumps, baseboard radiation, zone valves, and thermostats, it's easy to troubleshoot if you have a problem. Are your boilers running? What temperature is the water leaving the boilers? Are your pumps on? Are your zone valves opening and closing? That's pretty much it. But with heat pumps, it's not as easy to troubleshoot. And oftentimes you have to bring in a contractor when there is an issue, because you won't be able to figure it out because it has something to do with the refrigerant. Maybe you've got refrigerant leaks. Maybe you've got a failed fan somewhere or a failed compressor. So with heat pumps, you will have refrigerant lines running through the building. You might have a mini split. It's not that much of it isn't running through the building, so it's just coming up your outside wall. But if you have a variable refrigerant flow, a VRF system, those refrigerant lines are going to be running all throughout your building. Heat pumps are 2 to 3 times more efficient than electric resistance heat. That is a good thing to know. And oftentimes in new construction, heat pumps are paired with straight electric resistance heat. It's allowed by the energy code. But if you're doing a retrofit project, you can utilize the backup heating system, and that will allow you to not have to size down to the super coldest temperatures, because you have a backup heating system that you can utilize, which makes the whole thing a bit more cost effective. Cold climate heat pumps will work in Vermont, but some models will have both efficiency and capacity reductions at colder temps. There are kind of like grades of cold climate heat pumps. You can pay a premium to get units that when it gets really cold out, they don't lose capacity and they maintain a pretty good COP. But you're looking at, maybe a $2,000 to $3,000 premium on that. Controls can be really complicated when you're trying to integrate your new heat pumps with your existing heating system. So your existing heating system could be boilers with baseboard. They could be space Rinnai heaters. They could be a rooftop unit. It could be unit heaters. So the key is to link those together so that when your heat pump is running as your primary heat, that you have a way in which to signal to bring on the secondary heat. And does that mean your heat pump shuts off all altogether and you just switch over to the other system, or does it supplement? So these are the types of things that a person has to work out. And in commercial buildings, it can be fairly complicated and it can add cost to your project. And then the third thing is heat pumps do not typically provide fresh air ventilation. So if the system that is in the building right now is like a rooftop unit, those do bring in ventilation. You switch over to heat pumps, turn off your rooftop unit, you may be starving your space of ventilation air. So those things need to go and be thought of when designing. All right, Bryn, do we have any questions?
I don't see that any that have come in just yet.
Okay, all right. So the next thing is moving forward with implementation. You talk to your customer, I talked to my customer, I went through all those things. They said, yes, I'm still on board. And they said, we really want to do this for corporate reasons. Okay, so we've got the thumbs up to move forward. Here are the really critical things that I think these discussions need to be had with the customer before getting to the point of installing something. Number one is buttoning up, and that would be the phrase we use quite a bit for doing air sealing and insulation. That's the number one thing that should happen in the building. The second is to recalculate the peak heating load, because the original heating load was designed for the original building, and it maybe have been some safety factors in there. So we really want to look at what the new peak heating load is, factoring in the improvements in thermal shell. And then because your building has a backup heating system, here's an opportunity to undersize the heat pumps so that you can utilize the backup heating system and not have to install so many units or upsize the units in order to handle the really cold temperatures. Because you do lose some capacity as you get down into the colder temperatures. And I'll show you some graphs of that. So buttoning up, everyone has heard about button up the building, air seal and insulate. Well, there's a couple of reasons why in heat pump applications you really want to do this. So your existing heating system, let's say it's baseboard hot water, baseboard hot water is like 160 to 180 degrees, and that baseboard is going underneath windows and walls that maybe are poor performers. They're able to wash the cold air away, the radiative effects, and you feel warm in front of baseboard hot water. If you have a furnace, that air is coming out also at a really high temperature, like 150 or more. And we just know furnaces is like 120 to 150, but still it does a good job of washing away the radiative cold effect of windows or poor performing walls. The thing with heat pumps is they're only putting out air between 90 and 110 degrees. So they don't have the ability to deal with the radiative losses in a poor performing building. And that's the value of doing the buttoning up, so that overall you're going to feel more comfortable. If you were to put heat pumps in a building that had really poor thermal shell, it's likely that the tenants are going to be unhappy. In existing buildings, we try to go off the easiest stuff, which is going to be your attic cap and so the top and the bottom. These are all pictures that I've taken at different project sites. The one on the far left is a basement of a commercial building, and there's your basic rubble foundation. In that case, they did end up getting spray foam, and you want to get up into the rim joists. And then in terms of cellulose, doing the air sealing, and then getting, try to get maybe R60 up there. So with the air sealing, unfortunately, it takes effort. You got to get up in there, find out where the leaks are, seal them up with a foam gun, or maybe use a froth pack or a foam truck, and using some blower door guided air sealing. This is nothing new. This is what we recommend all the time. But it does take time, and it does take a contractor who's willing to go into the attic and find these leaks. And if you can do a pre and post blower, at least a post blower door test, so that you know what number to use in your load calculations. We do have a list of BPI contractors that do this type of work through our EEN. So calculating peak loads, this project example that I'm going to go through, these are real numbers, but I'm just using it as an example. So original building load calculation may not have been an actual calculation. Over the years, people have used rules of thumb on how to come up with the proper size boiler. It could be based on square footage, age of building, all of that goes into the kind of picking a boiler size. So in this case, the boiler input was 280 and the boiler output was 230. And the calculated building load that I did, given that I had the footprint and I knew how it was constructed and I had done a pre-blower door test, we were able to come up with a peak load of 218. The other thing to consider is if you have a peak load of 218, do you think an engineer is going to pick, a designer is going to pick a boiler for 220? Probably not, because they want to be sure that there's going to be enough load when it gets really cold. So in this case, the boiler output was 230. So it's not that bad of a match. But once you do the air sealing and insulating and you recalculate, in this case, this example building I'm going to go over, we were able to drop the load down to 149. So saved 68 kBTUH, which is a decent sized boiler. Just a quick note on heat pump performance. So nominal capacity, so if it's a 06 or an 09 or a 12, if it's a 12, that means that it's rated for 12,000 BTUH. That typically is not the heating output, but the cooling output. The heating output at design conditions can be significantly lower. So that's important when you come to picking the model number. You need to look at the fine details and not just the number in the model number. And if you're installing heat pump capacity to meet the coldest temps, you'll end up having to buy either larger heat pumps or more heat pumps in order to have enough capacity when it gets really cold. If you need 2 tons and your heat pump is rated for 24,000 BTUs an hour at 47 degrees Fahrenheit, but it's only rated for 12,000 BTUs at 0, and you need the full 24,000 BTUs, you're going to end up having to either put in a larger heat pump or put in 2 heat pumps in order to solve that. And when you get heat pumps that are really oversized, you end up having short cycling when you're in the like 30s and 40 degree outdoor air temperature. And a pitch for the NEEP advanced sizing tool. So NEEP is the database of all the approved efficiency Vermont approved cold climate heat pumps. And they have an advanced sizing tool, which is a different presentation that we've done. And it's worth taking a look at. It shows you how much your unit is going to be in short cycling and how well it matches the load of your building. So here's a snip from the cold climate database. I picked Mitsubishi units and they're all 20s. So their rated capacity for, I don't have their rated cooling capacity, but I picked their rated heating capacity as all the same, 22,000. But that's at 47 degrees. Well, I don't really care what my unit is putting out at 47 degrees. I want to know what it's doing at 5 degrees. So you can see based on the model, some of them will only give you half capacity at 5 degrees, and some of them will give you full capacity. I'm going to guess that the ones that give you full capacity at 5 degrees are going to cost significantly more than the units that give you half capacity. So there's some sort of a balance there in terms of, do you want to spend more on multiple heat pumps? Do you want to spend more on a unit that can go down to a colder temperature or that can have full capacity at a cold temperature versus undersizing because you already have a backup heating system? Now, they don't show you what it does at -11, but when you look on the NEEP database, you can see, you can kind of see it'll stop at 5 and then if you have data for the colder temps, you can put that into the database tool, and it kind of like projects what it could be doing at those lower temperatures. So here's a pitch on not sizing for peak winter conditions. 73% of all hours fall between 5 degrees and 45 degrees outdoor air temperature. So if you're sizing up or buying multiple heat pumps to cover 5 degrees and below, it doesn't represent a very large percentage of the hours of the year. And if you already have a backup heating system that can handle 5 degrees and lower, and that allows you to buy less heat pumps or smaller heat pumps, it makes the whole cost effectiveness calculation a win. All right, next is my example. So if anybody's got questions,
I have one question that came in.
sure.
So if you undersize BTU for heating season, how does that affect cooling?
That's a good question. So you're going to want to, that's a balance in terms of what you're going to purchase. Typically, we are finding that a house needs way more heating than it does need cooling. However, I have found that at least in commercial buildings and multifamily buildings that are built very, very airtight, they have a tendency to have a need for cooling earlier in, so like instead of waiting till not having to bring on air conditioning until it gets 70 outside, these buildings are needing air conditioning at lower temperatures at like 55 or 60 if they don't have operable windows. But that doesn't really impact the total peak. So it is something you want to look at, but it hasn't been a problem because heating needs have been significantly more than the cooling needs in a building.
Great, thank you.
No other questions?
Nothing yet.
Okay. So my project example, this is I work a lot with the state of Vermont on existing state buildings, and we look at buildings. We primarily have been looking at buildings that have high energy use index, so your kBTU per square foot. But every once in a while, we get a building audit request that comes through for us to go take a look at it. And this Kangar State Office Building in Hyde Park was an example where it wasn't an issue of the energy use index. There was another reason why they wanted us to look at going with heat pumps. So the reason why I decided to use this project as an example is that this building, there is nothing special about it. It is your typical office building, built in '86, wood studs. Its mechanical system is really simple. It's got baseboard hot water with oil heat. It's got electric water heater. It's got zone valves. It's got small circulators. It's got swish bath fan for exhaust. And the building is cooled with some window air conditioners. So you can see in this photo, there's one on the left-hand side, and then as you circle around the building, you'll see like another 6 or 7 of them. And this is the Attorney General's office. So they had uninsulated foundations and rim joists. There's all the window ACs that have to get pulled out come winter time, and they have the oil boiler. So the primary drivers for the state, the primary driver for us showing up were the first two things: upgrade building security and reduce the amount of maintenance, having to pull out those AC units and put them back in. They really saw the window AC units as being a security issue because a person could go walk up to the side of the building or put a ladder, push that window AC unit through, and now you have access to the building, and it's the Attorney General's office. And the state has a really strong state energy plan. for the whole state, in addition to just the state of Vermont, where they're looking to increase the use of renewable energy with solar, to electrify and overall reduce building usage by at least 30% as compared to the current code, energy code for new buildings. Just a little snapshot of what they use in the building. So they only use 1,500 gallons of oil per year. It's not a lot. And in my mind, my first thought would be, well, what can we do to reduce that oil? Maybe we could reduce the oil usage by half and only be 750 gallons by doing programmable thermostats and air sealing and insulating, and then maybe putting in an HRV. But what the customer was really interested in is looking at a heat pump system. So at the time that I did this evaluation, it was just about a year ago, they were paying $3.50 a gallon. And right now, well, the last report in from the Energy Information Administration for the state of Vermont was in March of 2023. The average cost was $4.06 for oil. And you can see it has been very volatile, going up and down. 2022, that's when we were up to the $5 a gallon. And 2021, it was low. It was in the $2 a gallon. But from a state perspective, if you're trying to budget your yearly oil costs, you could be going from this almost $3.50 a gallon of $52.40. And then if the next year or the next few months, all of a sudden you go up to $4.63, you're looking at more than $1,000 jump in your heating costs. And even though you haven't done anything in your building, it's just your cost of heating. So the volatility is there, and it is something that you can solve by doing electrification. So the first cost analysis I did was, let's just look at how much you would save if you did nothing to the building and you put in a bunch of 1-to-1 units, one for every zone in the building. So you've got a bunch of offices upstairs, some offices downstairs, and a stair column that goes from the basement up to the first floor. I used a seasonal coefficient of performance of 2.5. That is a little bit lower than a lot of the published data, but that is based on a couple of studies that people have done to try to calculate the real COP. And I think 2.5 is actually a little conservative. It was closer to 2.3. That's what we use in most of our calculations, is a seasonal COP of 2.5. So let's basic assumption that 99% of all of the heating oil has been offset by heat pumps. And the 1% of time, 1% of the oil boiler is still used for those really cold temperatures. And that the calculations were done at $3.50 a gallon for oil and 18 cents a kilowatt hour for Hyde Park. All you do is put in heat pumps, you're already saving $1,400 a year just in operating costs. Now, if the cost of oil went back down to $2 a gallon, that cost savings is really going to shrink. So instead of just going straight to putting in the heat pumps, let's look at what thermal shell upgrades could be done. Certainly the basement walls and the rim joists could have insulation added. Nothing can really be done to the exterior without having to dig up around the foundation, which is kind of is too much work and too disruptive to the building. The basement and first floor rim joists, because they have a drop ceiling, are easy to access in the basement where there is some offices. And then not really being able to do much on the exterior walls, except for maybe doing some weather stripping at doors and getting the windows closed in the wintertime or in the fall and spring, when normally the air conditioners are in there, could definitely benefit the building. And then do the air sealing and an attic cap. And I threw in 30% reduction in air leakage from my calculations. So this is the impact on the load of the building. The existing was about 1,500 gallons of oil. And doing all those upgrades goes to 940 gallons of oil. That's pretty good just for thermal shell upgrades. So now instead of spending like $5,200 a year, they'd be spending $3,200 a year. And remember the peak load that I showed you earlier was 218 and they have a 230 boiler. Now the peak load goes to 149. And you want to make sure that you have your blower door numbers to recalculate that. So let's look at the operating costs of the heat pumps with and without the thermal shell upgrades. So the one assumption is that the main assumption is that you're going to pick up 99% of the oil with heat pumps, and you'll still be using the oil boiler 1% of the time, a seasonal COP at 2.5, oil at 350 gallon, and that Hyde Park at 18 cents a kilowatt hour. So the original cost for the oil boiler per year was $5,240 to operate the oil boiler. Then switching over to heat pumps, but without any thermal shell upgrades, was $3,830. And now doing thermal shell upgrades and heat pumps, now your operating cost is $2,390. So you've cut your operating cost in half by making these upgrades, which is great. Now comes the question of, can we fine tune this even further by picking the right heat pumps and not sizing for the really cold temperatures? How are we doing, Bryn? Any questions?
We're doing well. No questions yet.
Someone's got to be questioning my calculations. I'm waiting for it.
Seeing it through to the next stages of the example, maybe.
Okay. So how many heat pumps? I purposely did not look at a VRF system for this building because it's a little bit harder to visualize. I stuck with the 1-to-1 units because people are really used to the 1-to-1 units. So,
and Mary Jane, can you just say what a VRF is?
Oh yes, variable refrigerant flow or variable refrigerant volume. That's where you can have one outdoor unit to like, I think many as 16 indoor heads. And that's where you have it varies the amount of refrigerant running through from the outdoor unit to the indoor unit. So for an office building that might have, I don't know, 10 zones, so 10 offices, every office would have their own like ceiling cassette or wall and a refrigerant line. And then the refrigerant lines all connect to one big box where you do the transfer, the magic happens, and then it goes out to the outside unit. So in those cases, the first cost is more. You have way more refrigerant lines running throughout your building. But the benefit is that if some zones are in heating and some zones are in cooling, there's the ability to transfer that energy in the heat, what they call a heat recovery box. A heat recovery box is an add-on. Otherwise, everyone has to be in heating mode or everyone has to be in cooling mode with a VRF system. Unlike a bunch of 1-to-1 units, everyone can do whatever they want. They can be in heating or in cooling mode.
Great.
So with the
we had a question we might get to at some point with the example, but cost comparison and lifetime payoff.
Oh yeah, we'll get to that. Yep.
Thanks.
That is critical. Okay. Operating costs. So if you were to stick with the existing system, or excuse me, the existing load, which was 213 or 113? 218. So the existing load is 218. You would need about 13 2-ton units. I assume that the 2-ton units were doing about, I don't know, 16,000 BTUs instead of 24,000 BTUs at 5 degrees or 0 degrees. If you do the air sealing and insulating, your load has dropped. Now you can go to 9 outdoor units to meet the needs of your building. So that's significantly less amount of money that you have to buy. Yes, you spend money on the thermal shell upgrades, but the number of units you have to purchase is less and your operating cost is less. So we'll get to the cost part of it, but visually you can see the impact it makes on the number of outdoor units. Now comes the question of sizing versus undersizing. So if you were to try and size for -11, I figured we would need about 9 heat pumps. That's at the lower load, 149. So 149 is the load that I calculated once we did the air sealing and insulating. And if you want to satisfy 99% of the load, you need to have enough heat pumps that can meet the load of 149 with maybe just 1% of the time with the oil boiler. But let's say instead of designing to meet the peak load at -11, you're designing only for 0. Well, now you only need 125,000 BTUs an hour, and you could go down to 6 units. But what if you were to size only for 115? Now, all of a sudden, you only need 5 units. So going from 9 units to 5 units is significant. And that is just has to do with undersizing. Why would you undersize? Well, you can undersize only if you have an existing heating system. And if you're starting from new construction, that's a whole different story because you don't have a backup heating system. You probably are going to want to size for -11 or maybe somewhere between -11 and 0 because you're going to have to run straight electric heat. On the right is an example of what a heat pump is capable of doing. This Mitsubishi unit is a 30,000. It's rated at 19,000. But look, at 5 degrees, the unit can do 23,000. So this is one of these units that has the ability to do great amount of heat at a cold temp. So you're going to pay a premium for this type of a unit. This will allow you to potentially have fewer heat pumps. So here's the great.
Mary Jane? Well, I'm sorry, everyone. It seems like we might have some technical difficulties. See if we can get Mary Jane back in a second here. Hopefully it's just a moment. Thanks for hanging in there. Yeah, if you want to add any questions in now, that would be great. Can make sure she gets those once she logs back on. And while we're waiting, let me put a couple links in the chat. Upcoming trainings, if you're not familiar with our website or on our events page, those can be found with this quick link. Those are updated regularly, and we try to always note if there's approved credits there. And then we have a save the date ready for our Better Building by Design conference for April 3rd and 4th for next year. If you're EM members, you can get a reduced discount, reduced rate for registering for that once registration opens. And then a last item while I have everybody. We released a number of flood related incentives this past week for residential, commercial customers, as well as for multifamily rentals. A quick link to that is just our efficiencyvermont.com website /flood. So hopefully that offers you all some a couple resources that that will be useful. So let me just check on Mary Jane. Again, sorry for the difficulties. And thanks for hanging in there. If folks want to stay on, certainly can try and give her another minute or so. I think at this point we might need to reschedule the second half of this. So actually, 1 second. Okay, sounds like she lost internet, so that'll happen. All right. Great questions. Keep them coming. There we go. All right, we got you back.
Hi.
Hi.
Champlain Valley Telecom. It's dropped me completely for 5 minutes. If anybody's still here, I can finish.
We have quite a few people still hanging out. So, and some questions that have come in too.
Okay.
Yeah, you've got a dedicated audience here.
Wow. Thank you. Okay. And then I'm going to put this back up, my PowerPoint.
We can
How is,
see,
is it okay?
We can see the notes version.
Oh. How about that?
Yeah, that's good. That works.
Okay.
Perfect. Do you want a couple questions to?
Yes, let's do some
Cool.
questions. We're almost to the end.
Perfect. Let me see. So if the goal of complete electrification is achieved in the future, undersizing will leave all the buildings without enough heat in colder temperatures. This will require additional expense that needs to be factored into the calculation.
Yep. That's definitely true. And I think those are the things that, as a building owner, you would need to look at. If you're not worried about how much money you're going to spend, like to make sure that there's a really good payback, then just go for it. But a lot of customers are worried about that first cost. And if they have a functioning backup heating system, and if it's hot water, then there's an option to go with the air to water unit at a later date. We also need to think about the fact that these mini splits have a life of about 15 years. And when that 15-year mark comes along, we're going to be switched over to a new type of refrigerant and all of the heat pumps. So unfortunately, that means that all the refrigerant lines have to be swapped out, as well as the indoor and outdoor units. And at that point, you could make some more changes to pick up the load of the entire building. And by then, your backup fossil fuel system will probably have been at the end of its life. But that's a very great comment. And it's something to consider. Right now, I'm just trying to do like successful baby steps with a lot of customers because they don't have the money to do the whole thing. And maybe it's you're picking up some offices that didn't previously have air conditioning, and now these people have air conditioning, and you're able to offset, 30% of the fossil fuel in your building.
Great, thank you. Another question. Is anyone making a small wood pellet boiler which could take care of just the peak loads below 0 degrees?
I don't know enough about wood pellet boilers to know how small of a wood pellet boiler. You would want a size for your peak heating, though, and that would be, in a home or a business, that can be anywhere from 20 up to 100 plus thousand BTUs. I like the idea of having a pellet stove, maybe, as a way to provide supplemental heat when a heat pump can't keep up. But in a commercial application, you can't, you're not going to see pellet stoves very often in a commercial building.
And then another question, undersizing units for heating via fewer units or lower efficiency units could translate to higher electric usage during lower temps. Is that correct?
Well, certainly it's not necessarily going to be higher electric. You're going to have more fossil fuel. There was one slide that shows what happens when you get so see the coefficient of performance, 1.89 versus 2. So at 5 degrees, it's not horrible. It's still pretty good. And for units that can go down, can still have good capacity at 5, you're not really paying much of a penalty. So yes, it's a difference of like maybe 2.8 versus 2, but it's not like you dip down into below 1.5.
Great. And then there was another comment that asked about how geothermal kind of correlates to some options for electrification.
I think I like geothermal because, well, geothermal is not as easy. There's a couple options in terms of retrofitting an existing building. So if you have an existing, let's say, furnace or rooftop unit and you want to go to geothermal, the question is, are you making hot water and cold water with a water-to-water heat pump off of a geothermal and then sending that to fan coils? So that's one option. You could also abandon or keep as backup like baseboard hot water and put water source heat pump units in every zone, and then rely on the constant circulating loop of the heat pump of the ground loop as your heat sink and a place to pick up heat. But that means you need to run those lines all around the building. I'm trying to think of what other options you would have if you were to do a water-to-water heat pump and you had like infloor radiation. That would be an okay way to do it. But then what are you going to do about the cooling? Are you going to have to put in fan coils? So it's a little bit trickier with a ground source heat pump because you need to have either a water loop running throughout the building, or you need to have some sort of radiators or fan coils to accept the cold and hot water that comes off a water-to-water heat pump.
Right. Thank
It's
you.
much better for new construction.
Yeah, that makes sense. All right, we have maybe 6 minutes or so
Okay.
until the hour. Maybe kind of roll
Okay,
to.
so where we left off was if you were to air seal and insulate your building at -11, you would need 149,000 BTUs. That's 9 heat pumps. Then if you were to size only for 0, you could get down to 6 heat pumps. If you were to size for 5, you would only need 5 heat pumps. Installation costs, my assumption was $6,000 per unit, meaning per 1-to-1 unit in the 1 to 2 ton range. And looking back at the original load of 218,000 kBTU, you would need about 13 1.5 ton units, which would cost you $78,000. But on the flip side, if you were to look at going all the way down to sizing only for 5 degrees and you did thermal shell upgrades, now your costs are only $30,000. So significant first cost savings in heat pumps going from 13 units to 5 units. Yes, you're still going to have some use of the boiler. I threw in $18,760 for the cost of air sealing and insulation, and that's based on cost per square foot of surface area for blown cellulose, for rigid insulation, for some spray foam plus air sealing. So the total cost of electrification, if you went with the load at 115,000 and 5 outdoor units, $48,760. So that's your cost of installation. Just a summary of the BTU reductions, and then we'll look at the paybacks. So we started with 210, and then we did the thermal shell upgrades. We went to 131, and then we looked at the heat pumps, comes down to 52. So the thing to remember is that heat pumps with their COP of 2.5, now your installed capacity is significantly less because of the COP. So here's the operating cost versus the first costs. We started out with an operating cost of $5,240 with just the oil. If you were to get rid of all of the oil except for 1%, and put in heat pumps, you're looking at savings in operating costs going down to $3,260. But remember that first cost was $78,000. So you're saving about $2,000, but you're spending $78,000. Then if you were to install heat pumps and heat pumps with air sealing and insulation, now you're at $2,390 operating cost, and that would be at the 149, so $54,000 for a first cost, plus the $18,000 for insulation and air sealing. And now if you were to undersize your heat pump, you can see that operating costs went up a little bit because you've added some cost to run the boiler more. But if you're sizing for 5 degrees outdoor temperature, you're only looking at a cost of $48,000. So even with going undersizing a heat pump, you're still looking at a 17-year payback. And that might be a little bit hard to swallow, but remember, we're starting with a really small amount of oil usage, only 1,500 gallons. And that's where I bring up the question of, could you do air sealing and insulating and do good thermostats and add in ventilation? And then at the end of the boiler's life, you could put in an air to water heat pump. There's other options out there besides going all the way right away to heat pumps. So I want people to think strategically about those options. The status of this project with the state of Vermont is that there was an actual project manager assigned with Buildings and General Services to start looking at the cost effectiveness and hiring an engineer to move forward with the project, but then the flood hit and a lot of the state employees have been spending time on dealing with all of the state buildings in Montpelier that were flooded and have been diverted away from some of these other projects. The thing I didn't include in this was any Efficiency Vermont or utility incentive, which could help bring that return maybe down to 15 years. So the key takeaways, not all buildings are a good candidate for full electrification. Doesn't mean you can't do some electrification, but maybe not the whole building. And that's where if you can get a customer who is a little bit nervous about doing it to do some of their building and feel like it was successful, then that I feel like is a win. Always air seal and insulate first. Always calculate new peak heating loads. Even if you don't do air seal and insulate, you should also recalculate the peak heating loads. You should pay attention to the specs of the heat pump equipment. What is it able to do at 5 degrees? Are you losing capacity? Are you losing efficiency? What happens if you oversize? Are you now going to have short cycling and have issues? Use the NEEP database, use their tool. If you ever have questions, feel free to reach out to me. After I did this presentation at Better Buildings, I had like 5 different people call me who were utilizing the NEEP sizing tool, and they were using it to figure out what was the right heat pump for their customer. Don't size for the absolute coldest day. Don't size for -20, -15, and even -11 might be too cold to try to size for. So look at what 0 would look like. Integrating controls for heat pumps and whatever the existing heating system are in the building can be complicated, and it's something that you really need to give thought to. Work with your engineer or mechanical contractor, work with the manufacturer of the heat pump to find out what thermostats can integrate with your old system. And of course, call Efficiency Vermont. There's other people like me that help with commercial customers. There's other people that work with residential customers. We have incentives available. We can help with finding contractors. We can help figure out what the right thermal shell upgrades are. We don't do design, but we can help you find people that can offer that service. And this is my contact information. Okay.
Well, basically, right on time. Even
wow.
For a short intermission.
Yeah. So I'm really sorry about that. It's been happening more frequently. It happened last Friday at like 3 o'clock, and it's like, oh, I guess I just am going to stop working for the day.
Yeah.
More questions?
We don't have any more questions at the moment. We do have a good number of folks that are still on the call. If you want to just put anything in the chat or raise your hand, you know, we lost a few minutes there, so we can stay on a little bit later for some Q&A too.
I'd be curious, is anyone doing these types of calculations for their customers? Or are customers asking for, well, how much am I going to save with a heat pump? Because I would want to know if I'm going to spend $38,000, I want to know if I'm going to save any money, or if it's going to add maintenance, if it's going to be complicated to operate. All those types of things come up in my mind.
Yeah, it sounds like, at least for Rogers customers, that they ask frequently for that information.
Yep. And unfortunately, it's, you know, a lot of little details that go into those calculations and figuring out which heat pump is the right heat pump. I suspect once contractors figure out what is the right combination, they can then kind of copy and paste it into other homes. But when you're dealing with bigger commercial buildings, there's just so many different components to the existing HVAC and options that make it not a copy and paste, unfortunately. But that's why we're here, to help you guys figure out maybe what's the right option for a customer.
A lot of different things to consider. So it sounds like Mass Saves offers a $10,000 incentive
For which system type, a VRF or?
Not sure just yet. Both.
Yeah, so that's pretty significant. Right now, all of our VRF incentives are custom. And if they're offsetting a fossil fuel, then a big chunk of the incentive hopefully will be coming from the utility company, whether it's GMP or a VEPSA customer, Vermont Electric Co-op. So we work with those utilities to try and facilitate that incentive that the customer would get for offsetting the fossil fuel, which is something that all the utilities have to claim. And then Efficiency Vermont would pay you for having a better than energy code heat pump system. But we don't have a prescriptive number for VRF. They're just not as popular as down in Massachusetts because we're slightly colder temperatures up here. And we do have our cold climate heat pump incentives, which are 350 or 450, depending on if you're under 2 tons or over 2 tons. And then depending on what utility you have, there's a time of purchase rebate from Green Mountain Power. There is a low to moderate income adder. And then if you have one of the other utility companies, it's possible you could additionally get incentives from them. And it's on our website in the rebate section.
Great, thank you. We also have business energy loans to help with financing. And then for residential, for our EM members, we have home energy loans to help with financing too.
Sorry about the internet.
Okay, we have one more question.
All right.
Earlier in the presentation, you mentioned a 40% federal incentive for ground source heat pumps.
Yeah.
There's a 30% tax credit. Has something changed?
I originally thought it was 30. Can you see my screen?
We're still looking at the slide deck.
Oh, I have to unshare. Okay. Can you see AHRI?
You stopped sharing your screen.
Oh, that's right. Okay. So I would Google that because I thought it was 30% and someone corrected me that it was 40%. It could depend on whether commercial or residential. And the website that I like to use is this federal DS DSIRE USA.org.
All right, I'll put it in the chat.
So this is a database of state and federal incentives. And you can click on your state and it'll tell you what's available. And you can filter. If you filter on federal. That's one place that I've gone to try and find information. Otherwise, you can just Google it.
Yeah, thanks for the resource. If there aren't any other questions, I know we're kind of creeping past the hour a little bit more here. Great conversation so far. Of course, you can always reach out to us, reach out to Mary Jane for any support at all. No question is too small. So